So we're going to review a little bit about energy that we talked about in the past. So we have hunter-gatherers. What was their main energy source?
The sun, fire.
The sun and fire. Good. Agriculture.
Animal.
Animal power. Good. Crops or wood. That's perfect. And then we hit today, which is one big disaster. So we went from hunter-gatherers using 100% renewable energy to agricultural using potentially renewable. Remember we talked about that? Taking it from a renewable state to a non-renewable or temporarily non-renewable. And industrial focuses on non-renewable. What are the types of non-renewable energy we're going to focus on? Fossil fuels involve three. What are they? Coal, which is first, petroleum, natural gas, and what's the last one? Nuclear. Good. Whoops. So non-renewable energy means that whatever you have has the potential to run out in your lifetime. Once it's used, it's not available. Okay? Now, can it replenish? Supposedly, maybe, yes. But we're going to talk about how fossil fuels came to be, and you're going to make the determination. So here are the words. Yes. We already have them. Coal, nuclear, natural gas, petroleum. The three fossil fuels, petroleum, natural gas, and coal. So these are some facts of industrialization. 82% of all commercial energy consumed in the world comes from non-renewable energy. So more than 75% or 3/4 of the world's energy use is non-renewable energy. So 76% of the 84% of energy consumed comes from fossil fuels. 82.
76 of 82?
Yep.
Do you think the fossil
The three largest consumers. Obviously, look at the color. I mean, that red.
where is that?
Use. So industry uses a big chunk of energy, 38%. Transportation is 27%. Residential and commercial, think of it as everyone else, okay? Commercial is like Archbishop McCarthy is considered commercial, it's a business. We're not manufacturing goods. That is the difference between industry and commercial, okay? So you're gonna say industry, number 1, transportation, number 2, and home and businesses 3. You don't really have to know these exact percentages, okay? Industry, 1. Transportation, 2. And home and businesses, 3. Not necessarily need to know percentages. Here's a chart for you. We're going to interpret this graph together. I'm not going to do it in the video. I'll reference the video I did. So the green is petroleum, the white is natural gas, and the blue is coal. Coal's main use is for electricity production, petroleum for transportation, and natural gas for industry. And here are, here's what we can piggyback on what Emily was saying. The projected energy consumption for the future, and as you see, they're all going up, and which one is just staying right there pretty stagnant?
Natural gas.
Natural gas. And look at nuclear too. Keep that in mind, bless you. Nuclear is pretty stagnant too. I'm going to spend a whole topic, we're going to talk about why that happened, even though there was funding for supposedly increase in nuclear power. And here's more, I mean, this one's actually from your book, more on coal and natural gas, which is the focus of this unit. So what is coal? Coal is a solid fuel, and it can be converted into gas or liquid. And the people that most use coal is the United States and China and India. So how was coal formed? Anybody know?
Dead dinosaurs. You know what?
It's compressed organic matter.
I love that. Compressed organic matter. What a perfect way to say it. So 300 million years ago, and the word swamp has to be tied into coal formation, okay? there were these giant plants and they died in the swamps. What's supposed to happen when a plant dies? It decomposes. Yet, somehow, millions of years later, it got buried and it was subjected to high heat and pressure and it fossilized. I guess I'm going to go over it. Partially decayed plants in swamps. This happens in stages, by the way, the formation of coal. We call this the pre-stage. Please. P for pre-stage. P for, anybody know what it's called?
Historic.
The first or the pre-stage of coal. It's a common thing that peat. See, I could see
How do you guys know
formation of peat. Happens all the time. But do we go from peat to the first stage of coal?
It'd take a long time for more peat to come on top of it.
Correct. And we're not going to see that. I've never seen it in my lifetime, I guess. Or maybe I haven't looked. So that's not really a stage of coal. They call it the pre-stage. You have to develop into this before you get into coal. So the first stage of coal is called lignite. What's happening in my picture?
Pressure. Water.
You're seeing some kind of pressure. What else are you seeing? Interpret the picture and don't think beyond the picture.
Being compressed.
It's what? It's getting compressed. I see that. What else do I see?
It's layered.
Losing water.
It's losing water and what?
It's layered.
It's getting deeper. Okay? Next stage is bituminous. You don't have to know sub. Bituminous, sub-bituminous, or bituminous. There's always going to be sub-layers. Like there's subphylums. So you go from peat to sub-lignite to lignite. You know what I'm saying? Okay. Again, now we can interpret something else. What else is happening?
Petrification.
Okay.
Turning into rock.
It looks like it's dry.
What else?
Is it dry?
Look, interpret the picture. What else do you see in the picture?
It's a lot more compressed.
I'm gonna give you the last picture. What are you seeing?
It's cracked.
Dry.
What?
Dry.
Okay.
Layered.
We got the layer, deeper, deeper, deeper. What else are you seeing in the picture? Look at the picture.
Hard
It's
lines.
shrinking.
It's breaking.
A bigger arrow, more pressure.
Okay, you're onto something with the arrows.
Red arrow.
Red, what do we see?
Hot.
Heat. Good. As the time went by, it was subjected to more heat and more pressure. Keep that in mind. So you go from peat to lignite to bituminous to anthracite. Peat is the pre-stage. So how many stages of coal are there?
4.
4. How many are actual coal?
3.
3. Lignite, bituminous, and anthracite. Some facts of the stages of coal. We know that lignite has low sulfur, and that's important because coal is associated with heavy amounts of sulfur pollution. But it's also low heat, so it's not the ideal substance for electricity production. As you go up, the heat concentration is higher. That means it's going to be converted into more useful forms of energy. Bituminous, more sulfur, more heat. And anthracite, highest heat, yet it has low sulfur. So which of the 4 is ideal? Anthracite. It's going to produce the most electricity with the least amount of environmental damage. Obviously the catch is there's not a lot of. The highest heat producer is anthracite. Most abundant, bituminous. I mean, I could say peat is actually the most abundant, but we don't use peat to convert it to electricity. It doesn't have enough heat. And here's a graph. Oh no, how do we get it? Who knows this answer? If I show you topsoil overburden,
That's surface mining.
that's surface mining. What's overburden?
Overburden is
Is it just soil and rock? And
It's what we want to remove because it's kind of bothering us.
It's like a burden.
It's the burden. Get it out of here.
over.
And what do we do with this overburden?
We
You put it in piles.
We just dump it there. And then when we're done mining, we kind of like fill it back up, right?
Ringo, you said exact picture of
You
this
did?
area.
I gotta fix that picture. So we use surface mining. That's not to say that sometimes people use subsurface mining to get coal, but the majority of the coal is found through surface mining. Major uses of coal. 88% of coal is used for electricity production. And what else is it gonna be used for?
Good.
Some forms, industry,
I mean,
good,
can you use
manufacturing of goods,
transportation and like the trains that use
correct.
coal?
But the majority is industry and electricity. And you have to know those two, that's it.
Which one?
In
Industry and
electricity, number one, and industry.
You guys know this?
No. How is coal transformed into electrical energy? I promise you, if you learn this, if you wait, and I'm saying this in the video, on learning this process, every single step of energy will be a burden to you. Because it all comes down to this genius idea. So, here is your coal-powered plant, let's say, and I'm gonna break down the steps for you. With burning, I'll go back about the processing, mining, putting it in the factory, cleaning, because that used to not even be a part of this process. Now we clean it first. But we already did all that. It's ready to be used. We're gonna burn it. Then we add water. The coal, the hotter, the more steam you're gonna get. The more steam, the more what? Anybody know what kind?
The more
Kinetic. What's a kinetic for?
The steam rises and pushes whatever.
The steam turns the turbine. The turbine is attached to an electric generator. Do you see it there in the picture? And you don't have to know about the electron current or any of that or how a generator works. What you have to know is that goes straight to your house. And then the water is cooled and it's either dumped into the ocean causing what?
High flow.
Thermal pollution, which causes what?
Less oxygen.
Less dissolved oxygen, or in a self-sustaining or efficient or sustainable factory, they reuse the water. Why don't they do this all the time? Because they have to recool the water, which requires energy. And if they're in the business of making energy, they're going to try to do everything they can to use the least amount and get the most. What type of energy transformations are taking place? You start with coal, which is chemical energy. Chemical energy is converted to heat, thermal energy. Heat to mechanical or kinetic or the motion of energy. And then electrical. To coal. And where do I get my advantages from? When I compare them to other non-renewable energy sources that produce electricity. Or renewable in that matter. So coal is relatively cheap, of course, because we own it. So here, and really throughout the world, if you look at coal prices per kilowatt hour, they're significantly cheap. Actually, all our energies are significantly cheap, as expensive as they seem to us. Most abundant fossil fuel in the world, and fortunately, we own it. We have the largest reserves of coal. And there's a picture of our coal reserves, and you see we have a lot of, different types of coal. Very little anthracite.
If we were to use it.
Good question. Then another advantage is that it's a high heat producer, so it's going to produce a nice yield of energy, of electrical energy. Because with every energy conversion, you lose energy. So you want to start with a lot to get some outcome. Disadvantages. Oh, another advantage is there's well-developed technology. So the obvious disadvantages is that coal is non-renewable and will run out. It's the dirtiest of all the fossil fuels. It produces more carbon dioxide and more sulfur oxides than any other fossil fuel. It accounts for 1/4 of the CO2 emissions in the world. And obviously we know that CO2 leads to the greenhouse effect and SO2 leads to acid rain. And any mining problem is going to be a problem with coal. There's a severe threat to human health when burned, and it emits toxins, even including radioactive chemicals.
Wait,